Hello dear students, today we'll talk about two very beautiful topics, gravitational potential and gravitational field. So gravitational potential is a scalar quantity and gravitational field or gravitational field intensity is a vector quantity. So what are the formula? Let's say this is an object of mass m and we want to calculate the gravitational potential and gravitational field due to this object of mass m at a point P, which is at a distance r from the object of mass m. Let's say this point is O. So here OP is basically r. Now at P, the gravitational potential is V equal to minus Gm by r. This is the formula of gravitational potential and it is a scalar quantity. We basically use capital V symbol to represent gravitational potential. Similarly, the gravitational field at P, this is the formula of magnitude of gravitational field. Actually, it is a vector quantity. That is why when we talk about gravitational field, then we have to talk about both of its magnitude as well as direction. So this is the magnitude of gravitational field at P. Now the question arises, how we will calculate the gravitational field? Actually, the rule is the point at which you want to calculate the gravitational field, you have to imagine a unit mass. At that point. Then the amount of force experienced by this unit mass is basically called the gravitational field. So how much force is experienced by this unit mass? According to the formula of gravitational force, G into m into 1 divided by r square. G m by r square. This is the force experienced by this unit mass. Now, since it is a vector quantity, that is why we have to know its direction also. So in vector form, we write a vector is equal to minus Gm by r square into r hat. This is the vector form and this is the magnitude only. So why these negative sign arise? Actually, if you see carefully, then you will be able to see it. The force experienced by this unit mass is basically in this direction. Why? Because gravitational force always attractive in nature and this object attracts this unit mass towards it. That is why this is the direction of gravitational force experienced by this unit mass. And here the distance r is basically measured with respect to point O. So in vector, the direction of r vector is basically this. This is the basically direction of r vector, OP. This vector is basically r vector because the distance r is measured from the point O. Now if r vector is in this direction, then r hat will also be in this direction. But see here carefully, force experienced by this unit mass is in this direction and r hat is in this direction. So they are opposite in nature. That is why this negative sign arises. So why this negative sign arises? Actually, this negative sign arises to represent that the direction of gravitational field is always towards the mass. The direction of gravitational field is always towards the mass, due to which we are calculating the gravitational field. So you can also write here that gravitational field is a vector quantity and its magnitude is Gm by r square, where m is the mass of the object due to which we want to calculate the gravitational field, and the point at which we are calculating the gravitational field, this is r distance away from this object, and its vector form minus Gm by r square into r hat. So we can write the direction of gravitational field, G dot F, gravitational field, is always towards the mass due to which it is calculated. Now we will see few numericals on the basis of gravitational field and gravitational potential. Then things will be more clear for you. Let's see this question. 4 particles, each of mass m, are located at the vertices of a square of side A. Find the gravitational potential and gravitational field at the center of the square. So how we will calculate it? Let's say this is the square having side A and m mass is located at each of its vertices, and A is the side of the square. So that point O is basically the center of the square. Now at O, the gravitational potential is, for this object, the gravitational potential at O is basically gm by this distance. We all know that this is a square, so this is diagonal, and this length is called half of the diagonal. So the length of this diagonal is a root 2, and half of diagonal will be a by root 2. So at O, the gravitational potential due to this mass m is basically minus gm divided by a by root 2, because this distance is a by root. Similarly, at O, the gravitational potential for this mass m is also minus gm divided by a by root 2, and that will be the gravitational potential at O due to these two masses also. Since gravitational potential is a scalar quantity, that is why due to all four objects of mass m, the total gravitational potential at O will add. So total gravitational potential is V equal to 4 times minus gm divided by a by root 2. So the formula is V equal to minus 4 root 2 gm divided by a. This is the gravitational potential at O. Now we will find the gravitational field at O. At O, the gravitational field, what will be the value of gravitational field? Actually, all these distances are same because they are basically half of diagonal, which is a by root 2. So here, let's say small r equal to a by root 2. Let's say small r equal to a by root 2. So the value of gravitational field at O due to this object of mass m will be gm by r square, but its direction will be towards the mass. Similarly, for this object also, the value of gravitational field at O is gm by r square, but its direction is also towards the mass. Similar rule will be valid for these two objects also. Their value will be gm by r square, but their direction will be towards the mass. So just see here carefully, all these vectors, since gravitational field is a vector, they are equal. If you consider these two vectors, they are equal in magnitude because their magnitude is gm by r square, but their direction is opposite to each other. So what will happen? They will mutually cancel each other. Similarly, these two vectors are also equal in magnitude, but they are opposite in direction. That is why they will cancel out each other. And the total gravitational field at O, total gravitational field at O is 0. This is the formula of gravitational field. Why? Because it is a vector quantity. Let's see another question. Infinite number of bodies, each of mass 2 kg, are located on x-axis at distances 1 meter, 2 meter, 4 meter, 8 meter, respectively from the origin. The total gravitational potential, G dot P means gravitational potential, at origin due to this system is, and these are the options. Actually, this is the previous year's questions of NEET. So how we will solve it? This is x-axis. Let's say this is origin, and this is 1 meter away from origin. So 2 kg object is here. This is 2 meter. So another 2 kg object is here. This is origin O. This is 4 meter. Another object of mass 2 kg. This is 8 meter. Another object of mass 2 kg, and so on. So here total gravitational potential at origin will be minus g into 2 divided by 1 plus minus g into 2 divided by 2 plus minus g into 2 divided by 4 plus minus g into 2 divided by 8 plus Why? Because here the mass of the object is 2 and the formula is gm. G into m is mass, and for that one the distance is 1, for that one distance is 2, for that one distance is 4, and so on. So if we take minus 2g common, then that will be 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus up to infinity. So now if you see carefully, this is basically infinite GP series, where the first term a is basically 1 and the common ratio we basically use small r to represent common ratio and a to represent first term. So here small r is basically half. So what will be the sum of this entire series? Minus 2g. Formula for finding infinite GP series is basically a by 1 minus r, where a is first term, r is common ratio. So here 1 divided by 1 minus half. So we can write minus 2g divided by 1 by half. So this result will be minus 2g into 2 equal to minus 4g. That will be our option, minus 4g. Let's see this question. Infinite number of bodies, each of mass 3 kg, are located on x-axis at distances 1 meter, 2 meter, 4 meter, 8 meter, respectively from the origin. The resulting gravitational field G dot F gravitational field at origin is, and these are the options. So how we will solve it? Just imagine this is x-axis, that point is origin O, and this is 1 meter away from this origin. This is 2 meter, this is 4 meter, this is 8 meter, and so on. So 3 kg object is here, here. So these are the positions of 3 kg. Now total gravitational field at origin will be equal to the sum of gravitational fields due to all these objects at origin. So for all these objects, the gravitational fields are respectively g into 3 divided by 1 square plus g into 3 divided by 2 square plus g into 3 divided by 4 square plus g into 3 divided by 8 square plus infinity. Now from here, if you take 3g common, then that will be 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus infinity. So if you see carefully, this one is also an infinite GP series. So we know for infinite GP series, A is called first term and R is called common ratio. Here the common ratio is 1 by 4. So the sum of all these infinite GP series will be A by 1 minus R. This is the formula for finding sum of infinite GP series. So here the result will be 3g into first term 1 divided by 1 minus common ratio 1 by 4. If you solve it, value will be 3g into 4 by 3. So 3 will cancel each other. 4g is the result. So total gravitational field at origin is 4g. This is the method by which you can calculate total gravitational field or potential at any point. Read this topic carefully. Note down it in your copy. See you in the next video. Bye.